Hello YouTube, this is Mr. Bakari and today we are going to talk about vectors. So this video will be an intro to vectors and then it will be followed by several videos that will take you through the unit. Okay, so the first question we want to answer is what is a vector? A vector is a quantity that has both magnitude and direction. So here it is depicted by an arrow. The arrow has a tail and a head and its length is its magnitude. So the longer the arrow, the larger the magnitude. And the arrow is pointing to a specific direction, and so it has direction and magnitude, therefore it is a vector. One thing you want to take note of is location of a vector does not matter. So we could move this vector over here to the left, we could move it down, and as you can see, we have maintained magnitude and direction. It is the same vector. So location has no bearing here. All right. So we write vectors in component form. And component form is made up of a change in x followed by a change in y. And we use these arrow brackets on the ends, okay, to show it's a vector. So, for example, if we take this vector over here to the right, this red arrow, we could say if we go from the tail of the vector to the right, 1, 2, 3, 4, 5, and then we go up 1, 2, 3 to the head of the vector, then we could say that the change in x is right 5, comma, and the change in y is up 3. We could put our arrow brackets at the end and we have the component form of this vector. So we show direction here by the change in x and the change in y. All right. Now, of course, this vector has magnitude. Now, to find magnitude, we are going to use the distance formula. And magnitude, this symbol is given. So you'll see your vector with two pairs of vertical parallel lines on each side, and that just means magnitude. Okay? So magnitude of a vector is its size. And what that size means depends on the context. Okay, so here up here in the top corner, our arrow, the magnitude is represented by the length of the arrow. But in physics, magnitude is represented by physical strength or intensity, usually measured in newtons. So it's given a numeric value, and that represents its strength or intensity in, say, newtons. All right. So let's find the magnitude of this vector using the distance formula. So we have the change in x here, and we're going to square that, and we're going to add it to the change in y, and we're going to square that. We're going to take the square root of that, and we get the square root of 34. So the magnitude of vector v, and I can use these pairs of vertical lines on each side to show magnitude, is root 34. Okay? All right. So in this example, it says W has an initial point at 3, 1 and a terminal point at 2, negative 3. So initial point would be where we start, and the terminal point would be where the vector ends. All right. It says find the component form and the magnitude of W. So to find the component form, we are going to look at the change in x, which is down 1, and the change in y, which is down 4. We'll put our arrow brackets on that, and that is our component form. Okay? Now, again, to find the magnitude, we are just going to take the change in x, square it, add it to the change in y, squared, and take the square root. So we get the square root of 17, and that is our magnitude. Okay? All right. So now we're going to find a unit vector. A unit vector is a vector with a magnitude of 1. Okay, so we start with a given vector here, v, and we want to find a vector that goes the same direction but has a magnitude of 1. And over here to the right is the symbol for this. And what this says is the unit vector equals your given vector divided by the magnitude of that vector. So what we need to do is we need to find the magnitude of vector v first. So I'm going to do that first. And you will get root 13 as the magnitude. Okay? So following our symbols over here, the unit vector will be the change in x divided by the magnitude, the change in y divided by the magnitude, and now we have our unit vector. Okay? Now over here, I can kind of show you what we're doing. So I'm just going to draw a vector on a coordinate plane here, just like that. And with a right triangle, we can see that the change in x was 2 for vector v, and the change in y was 3. And the magnitude was the square root of 13. And you can kind of check that out using that right triangle, and you can see that Pythagorean theorem or the distance formula will give us the magnitude given the change in x and the change in y. So this vector has a length of square root of 13. Now, we changed to a magnitude of 1, which means now the change in x is 2 over root 13, and the change in y is 3 over root 13. So this is just depicting what we did over here with the math, okay? This is our unit vector. Now you might be wondering, why do you need to find a unit vector? Suppose a force acts in some direction given by a vector. If we find the unit vector, we can then turn around and multiply it by a scalar, say 10, and now we have set the strength, right, or force of that vector to 10, or whatever we might want it to be. Okay, and that is a popular, right, application of why you'd want to use a unit vector so that you could then scale it to whatever you'd like. So we're going to end this video with one direction like that. So we'll read this together. If you want to pause the video and try it yourself, come back and we'll go over it. It says, find a vector in the same direction as b with a magnitude of 12. So here is vector b. Okay, so the first thing we want to do is we want to find the magnitude of vector b. So I'm going to use my distance formula. And the magnitude is the square root of 26. Okay, so then to find my unit vector, I'm going to take the change in y over root 26, comma, the change in the change in x over root 26, the change in y over root 26, put my arrows, and now I have a unit vector, okay? And so the question wants us to find a vector that goes the same direction, but has a magnitude of 12. And now I will bring in that scale factor of 12, multiply it by our vector, and we should get a vector with a magnitude of 12. So our final answer is 12 over root 26, comma, 60 over root 26. And that's how it's done. Okay, so I hope this gives you a good idea of what a vector is, a few components of it, the basics, and hopefully I will see you in the next video and we will take this a little deeper. Until then, be safe.